Okay, in today's lesson, we're going to be talking about some intercepts and also the idea of slope. So, first of all, some definitions to get us started. The y-intercept is the point where the graph touches the y-axis. The x-intercept are the points or point where the graph touches the x-axis. So, we could have more than one x-intercept for a graph. This can also be asked by using the words roots or zeros. So those three words are interchangeable: x-intercept, roots, and zeros. And then the slope refers to the steepness of a line or the rate of change. All right, so we're going to take some time taking a look at how we can find slope using two different methods. The first way, we're going to utilize the idea of rise over run. So this is vertical change over horizontal change. So looking at my example that I have listed there, we have a line and we see that the bottom point has been identified. So I'm going to start at this lower point and I'm going to rise 2 units to get up to where it's parallel to the second point. So my rise in that scenario is 2. Then I'm going to run, which run means horizontal change, 1, 2, 3, 4. So my run is 4. I moved up, which is positive, and right, which is positive. So my rise is 2 over my run is 4. These can both be divided by 2, so the reduced form of my slope would be 1/2. So rise over run, we're finding the differences between the y values, and then we're finding the differences between the x values. It's actually no different than using the formula y2 minus y1. We're finding the difference in the y values and dividing it by x2 minus x1, which is the difference between the horizontal values. So taking a look at this example, we're going to go ahead and locate our points. This first point is at 1, 2. And the second point, our second point is at 1, 2, 3, 4, 3. So we're going to use the slope formula on this one. Since this is my first point given, I'm going to label the 1 as x1, the first y value, and the 2 as the first y value, y1. My second point has an x coordinate of 4, so that's x2, and a y value of 3, so that's y2. So those subscripts just refer to what point are you looking at, the first point or the second point. All right, let's go ahead and substitute that into the formula. So my y2 value is 3 minus my y1 value is 2 divided by my x2 value is 4 minus my x1 value is 3. Let's go ahead and simplify that. So 3 minus 2, we get 1. And 4 minus 1, we get 3. So I get a slope of 1/3. The variable that we use to refer to slope is m. So m equaled 1/2 on the first example, and m equals 1/3 on that example. Now let's use the idea of rise over run to see that we would get the exact same thing if we were to use rise over run on the second example. So I'm going to start at the lower point. My rise is 1, so I'm going to go up 1. And my run was 3, so I'm going to move to the right 3 units. And we see that we do get to our second point. So again, I could use rise over run to get to that slope, and I would get the same exact results. Here are two more examples that we're going to go through together for finding slope. On the first one, I'm going to use the slope formula since the grid or the graph paper is not shown. It might be difficult to count that rise and run without seeing those boxes on that graph paper. So I'm going to call this point my first point, so labeling x1 and y1. And the higher point, I'm going to call my second point. So again, labeling x2 and y2. All right, our formula looks like m equals y2 minus y1 over x2 minus x1. So substituting in these points, y2 is 3 minus y1 is negative 1 divided by x2 is 4 minus x1, which is negative 2. Be careful with those minus negative values. So leave change, or however you want to refer to that, but minus a negative actually means addition. So we're taking 3 minus a negative 1. That means the same as 3 plus 1, which is 4. And 4 minus a negative 2 means the same thing as 4 plus 2, which is 6. We do want to check to see if we can reduce this fraction. So they're both even, so let's divide them both by 2. 4 divided by 2 gives me 2, and 6 divided by 2 gives me 3. So we have a slope of 2/3. Okay, example 2, I'm going to go ahead and use rise over run on this one since I used the slope formula on that first example. I'm going to start at this bottom point and determine how many units do I have to rise. So going up, 1, 2, 3. I have to rise 3 units. So the rise is 3. And we're going to run 1, 2, 3, 4. Notice that I had to move left. So left is negative. So my run is negative 4. All right, the rise was 3. And the run is negative 4. It doesn't really matter where you put that negative sign. You could put it with the numerator, you could put it with the denominator, or just out front. But be careful, we can't make both the 3 and the 4 negative because then that would indicate a positive slope or an increasing line. Our line is definitely decreasing. It's going downhill. So we do want a negative value for slope. I'm just going to pull that negative sign out front and say it's negative 3/4. Okay, so those were our two examples for slope. Okay, this next example, guys, I'd like you to try. So pause the video here, see if you can find the slope. I would do number 1 using rise over run and number 2 using slope formula. Unpause the video to get the results. Okay, for these two examples, we see that we get negative 2 for both slopes. So on number 1, I used rise over run. The rise was 4, the run was negative 2. I did reduce that fraction to again get negative 2. For number 2, we use the slope formula. So labeling the numbers x1, y1 and x2, y2. Plugging those values in, we get 8 minus a negative 2, which is positive 10. 8 plus 2 is 10. And negative 6 minus a negative 1. Negative 6 plus 1, that gives me negative 5, which again reduces to negative 2. Okay, so far we've seen that we can have both positive and negative slopes, but we can also have undefined slopes or slopes that are 0 depending on whether we have a vertical or horizontal line. So let's go ahead and pick 2 points on this vertical line. I'm going to pick negative 2, 1. And negative 2, 3. If I were to go to find the slope of these 2 points, I see that the rise is 2, but the run is 0. 2 divided by 0 is undefined. We cannot divide by 0, so that's why we get an undefined slope there. For the horizontal line, if I pick 2 points, again, I'm going to pick 1, 2, and let's say 3, 2. Now we see that the rise is 0. We're not rising at all to go from one point to the next. We're just running 2. And 0 divided by 2 is 0. So that's why we get 0 slope for those horizontal lines and undefined slope for the vertical lines. Of course, we could have negative and positive slopes as well. Okay, we may be asked to interpret slope or what is the rate of change. These are ways that they could ask us to find the slope of a line and interpret the slope. So taking a look at this example, we have time on the horizontal axis and distance traveled on the vertical. And this is representing a bike ride by Mickey. So it's asked, what is Mickey's rate of change? That's just another way of asking what's the slope of the line. So let's pick out our 2 points. There's a lot of different points that we could pick, but I'm going to select 26 as my first point, and I'm going to select 40, 12 as my second point. I'm going to go ahead and use rise over run. You could use the slope formula if you'd like instead. So we see that the rise goes from 6 to 12. So that's a difference of 6. So we're rising 6. And then the run, we are going from 20 to 40. That's a run of 20. Okay, rise over run. So 6 over 20. That can reduce. If we divide them both by 2, we would get 3 over 10. If we think about units, the rise is changing the distance in miles. So 3 miles for every, the X is representing minutes. So Mickey's traveling 3 miles every 10 minutes. Now, it might make more sense for us to go ahead and divide that for this particular example. So if I divide 3 divided by 10, I would get 0.3. So Mickey is traveling 0.3 miles per minute. So that's Mickey's speed. This slope is talking about how fast Mickey's traveling. So his speed is 0.3 miles per minute. Okay, here's another example, but this one doesn't give us a graph. So for this particular scenario, I'm going to read through it and see if we can identify 2 points. A teacher weighed 190 pounds in 1996 and weighs 145 pounds in 2007. What was the rate of change in weight? Okay, again, rate of change is just a fancy way of asking you what's the slope. So let's identify our 2 points. In 1986, this teacher weighed 190 pounds. In 2007, the teacher weighed 145 pounds. So those are our 2 points. Let's go ahead and find the slope. So this is going to be my x1, y1, and this is my second point, x2, y2. So if we go ahead and subtract y2 minus y1, 145 minus 190, and I'm dividing that by 2007 minus 1986. All right, 145 minus 190 gives me negative 45. And 2007 minus 1986, that gives me 21. So this teacher decreased 45 pounds in 21 years. Now, we could reduce that. I think they're both divisible by 3. So if I divide them both by 3, that would be negative 15 pounds every 7 years. And again, I could go ahead and divide negative 15 divided by 7. That's going to be just a hair over 2. Let's see what that is. Negative 15 divided by 7 gives me negative 2.14. And the unit would be pounds per year. So this teacher is losing 2.14 pounds every year. Okay, so now we're going to start to take a look at not only slope, but also the Y-intercept and the X-intercept. So the points where the Y-axis is intercepted and the X-axis is intercepted. Notice that when we have a Y-intercept, the X value is 0, and then the Y is wherever it is on the Y-axis. When we have an X-intercept, we have a number for X depending on where it touches, and the Y value is now 0. Okay, so for our first example, we just want to find the values for the X and Y-intercept, making sure that we can state what the Y-intercept is and what the X-intercept is, but also what the coordinates are. So taking a look at the Y-axis, we need to see where does it touch the Y-axis. So if I go ahead and focus on this vertical axis, the Y-axis, we see that it touches right here at negative 2. So our Y-intercept is negative 2. But we should be able to write that as a coordinate. We do not move left or right, so our X value is 0, and then we move down 2. So the Y value is negative 2. So our coordinate is 0, negative 2. Taking a look at the X-axis, we want to figure out where does the line touch that X-axis. So taking a look, we have to move left 1, 2, 3 to get to that point where it touches the X-axis. So our X-intercept is at negative 3. And the coordinate, we move left 3 and up or down 0. So our coordinate is negative 3, 0. So we've already talked about how to interpret the slope. I included that on this slide just to get some more practice, but we also want to interpret the Y-intercept and interpret the X-intercept for these scenarios. So taking a look at this particular graph, we're comparing number of weeks with the amount owed on a laptop. So first of all, interpreting the slope, we'd have to pick out 2 points that are on the line. I'm going to go ahead and select the 2 that are already identified. So we have this point at 0, 1,000, and we have this point at 10, 0. So I'm just going to use those 2 points. To find the slope, the rise would be 1,000. And the run, I'm moving left 10 units. So that's negative 10. I'm going to go ahead and divide these. So 1,000 divided by negative 10 gives me negative $100. So to interpret this, I would say the amount of the loan is decreasing $100 per week. So they're making payments on their laptop of $100 per week. So they're owing less and less on that laptop as time progresses. Okay, the next item, we're interpreting the Y-intercept. So the Y-intercept is where it touches the Y-axis. And that's this point that we've identified right here at the top. So we see at 0 weeks, we owe $1,000 on the laptop. So that's my interpretation of the Y-axis. At 0 weeks, oops. The amount owed is $1,000. So that's like the initial loan amount. So we're taking out the loan for $1,000 and we're going to, again, start to make payments. But when we initially take that loan out, we owe $1,000. Interpreting the X-intercept is where it touches the X-axis. So if we look, here is where it touches the X-axis. That X value is 10. So it takes 10 weeks to pay off the loan. Because at 10 weeks, we owe $0 on the laptop. So that's when it's paid off. Okay, this concludes the notes for today.